semester that I called the cluster analysis. And you know what? I introduced cluster analysis to you on Friday. We actually going to continue from this, from where we stop today. We're going to continue from where we stop on Friday right now. You know what? I attached the cluster worksheet. I also attach the arrow material. I'm actually going to walk you through those, those two materials today. So I could remember I introduced you to cluster analysis. Okay. So, and by now, the essence of cluster analysis is just for us to be able to classify items, individuals, objects, into different categories. Okay, and I told you the difference between the cluster analysis and classification analysis. Okay, in cluster analysis, we don't actually know the number of groups that we actually going to partition the items into, and that is only determined in the course of the analysis. Okay, the number of groups that we're actually going to partition the object to object into will only be determined in the course of the experimentation. But for the discriminant and classification analysis, before we partition into groups, we have the advanced knowledge of the group. Okay, so I could remember I walk you through what we call, I showed you some similarity measures, what we call the Euclidean, the statistical, and so on like that. I showed you this last week, and these are measures of similarity. Okay, and you know what? If I want to measure similarity, of course I need to calculate the distance. Okay, if the distance between any two items or any two variables, if the distance is not very much pronounced, then it means they are more or less similar. Okay, because we know from the biological point of view, as put forward by Professor Charles Darwin and Lamarck in the theory of evolution, we know that no two human beings are genetically the same. Therefore, if no two human beings are genetically the same, then if we are to compare items or human beings or whatever, we actually going to notice a distance. Okay, but you know what? The moment the distance is not very significant, okay, yeah, then we can actually more or less classify those individuals into the same group. Okay, it is only when the similarity, okay, if there's a great in the distance, okay, between them, that we can actually say, okay, this shouldn't be grouped together. I remember I also walk you through the similarity coefficient for binary outcomes. Okay, I showed you this last week, Friday. Okay, and I remember we work on this example because if you're given a data set like this data set is actually binary in nature. Okay, you got a 8 4, okay, and you got a 6 variables. Okay, and if you take a look at each of these variables, they are categorical. Okay, categorical in the sense that they can assume 1 or 0. Okay, and you know what 1 means right here. Okay, artifact type greater or equal to 48. So in a situation where all the variables are categorical in nature, okay, and you have so many faults, this way you can, they ask you to compare. The goal here is just to group 8 Canadian faults, okay, to group 8 Canadian faults, okay, and this is a data set that you're given, okay, you're given data set, okay, this data set, okay, and you know what, you can actually set up a similarity matrix, okay. So now I walk you through how you can set up a similarity matrix last week. And you know what? And I also show you how we are able to partition, okay, how we are able to partition, uh, you know, uh, the 8 Canadian forts, okay, into 3 subgroups. Look at that, 1, 2, 3, okay. So, I show you this last week, and you know what? Before the analyst or the researcher do not have the advanced knowledge that we're actually going to have 3 groups at the end of the day. We didn't have that knowledge, okay? This was actually determined in the course of experimentation. And you know what? I show you this, how to get the similarity index, okay? I walk you through that last week. Okay, so in the similarity measure, okay, in the similarity measure, the ratio of 1 divided by 1 plus the distance measure, because there's a connection between similarity measure and the distance measure. Now, what you are seeing right here, okay, if we're similar, okay, then our distance will not be far apart, okay. And let me tell you this, and that is the reason why, if you take a look at what I have here, the similarity and the distance are inversely related, okay. They are inversely related in the sense that if the distance between us is very, very small, then the value of the similarity will tend to increase, okay. So they have inverse relationship, okay. The more the distance, the less will be the similarity, okay. And you know what? The similarity that we talk about actually lie between 0 and 1, okay. Do you know why it's actually going to be greater than 0? Because similarity cannot be 0. Similarity, why is it that similarity cannot actually be 0? Is actually because of the fact that we cannot exactly look, you know, we can't exactly look alike, and we cannot totally be different from one another. That's what I want to tell you right now. We cannot exactly look alike, and we can look alike probably in terms of maybe either black and white or stuff like that. And not only that, in terms of weight, in terms of ability, in terms of, you know, any characteristics of interest you can think of, we cannot exactly, you know, look alike. And you know what? We cannot be totally different from one another, okay. And that is the reason why the similarity have to be greater than 0, and you know, this is the range of that. And of course, we can have a similarity matrix, okay. And you know what, in a situation, if you take a look at this, when similarity equal to 1, because I want to tell you, in reality, this is not possible. In reality, okay, when no, and that was why I said non-negative, definite, and maximum similarity, maximum, okay. And that is a situation where you're gonna have 1. And you know what? We actually have a connection between similarity and the distance. If I have a similarity, can I actually determine the distance? Okay, so that is a similarity. So what I have in this page is actually talking about similarity and the distance measure. Okay, and I walked you through this last week about, you know, the idea behind here is just for us to be able to derive the correlation, okay? Because at times we may actually want to have a measures of association, okay, among the variables, okay? But you know what? The variables have to be categorical, okay? The variable that we're talking about have to be categorical, okay? Where we can actually say that, you know, the A here will be the number of, you know, the number of matches, you know, that they have for 1 when the first variable is 1 and when the second variable is 1. Okay, now how many times do we have that? Okay, and when the first variable is 0 and the second variable is 0, how many times can we have that? And B and C are more or less like a mismatch. How many times do we have that? Okay, so what if your examiner asks you to find the mean? What are you going to use out to find the mean of X, the mean of Y, the sum of square deviation of X, the sum of square deviation of Y, and the cross, the sum of square products, and eventually ask you to find the correlation. Okay, so these are and you can see that the mean, the mean of X, the mean of Y, the sum of square of X, the sum of square associated with Y, the sum of square product, and the correlation, everything are expressed in terms of A, B, C, D. Okay, A, B, C, D. It means the moment you know your A, you know your B, you know your C, you know your D, you'll be able to find anything here. Okay, so, and I show you, well, based on the data set that we have, of course, I showed you last week how you can actually compute the correlation, okay? And I told you the meaning of, I told you that concur is just A plus D, okay? And that is what we mean by concur. Now, when I say A plus D, why do I say concur? If you go back, A and D, A plus D, that is the total number of matches. Concur means agreement. Okay, that's an agreement. Okay, so that is just the number of times, the two variables we actually agree. Okay, so and that is why, so A plus D is concur. So concur means agreement. Okay, and that's what you have right here. Okay, and you know what? So when I know that, because an examiner can actually ask you to find concur. So when I say concur, then I mean what is the total number of agreements? Okay, the number of time the two variables actually agree with each other. Okay, so the number of time they agree with each other is just for you to add the number of time they tally as coded 1 and the number of time they tally as a coded 0. Okay, so that's exactly what we mean by concur. Okay, and of course we can actually find the correlation between the pair of the variables. Okay, I could remember where we stopped last time was about hierarchical clustering method. Okay, hierarchical clustering method. So that was where we stopped, and I told you we got three ways. Okay, three methods under the hierarchical. We got the we got what we call the agglomerate method. We got the linking strategy for combining clusters. We got the divisive method and the dendrogram. But let me confirm to you that in the final exam, the probability that you're actually going to see a question that we have to do with the linking strategies, the probability is 1. Okay, so you are likely going to see a question on single linkage, on the complete linkage, and on the average linkage. And after that, of course, you're actually going to see a question where you need to provide the diagram, the dendrogram. Okay, and I'm actually going to walk you through that today. Okay, now I want you to follow me with the way I'm actually going to be doing that. Okay, so I'm going to walk you through how to do a single linkage. The single linkage is a minimum distance. A complete linkage is a maximum distance, and the average linkage is a mean distance. So, like I said, I'm confirming this to you, that this is actually going to be the part of the exam. Okay, the single linkage, the complete linkage, the average linkage, and the dendrogram. I'm actually going to walk. Can you guys hear me?
Yes.
Okay. If you look at the question that I just uploaded on the practice question, you're actually going to see question that has to do with this. Okay, so please, I want you to just sit down and just take a look at what I'm doing right now. If you have any question, please make sure you ask. Now, we got an example right here. You are given 5 WNBA players. These are basketball players. Okay. And you can see them. There are 5 of them. Okay. And we believe that these 5 players actually have, in terms of abilities, okay, they are not the same. And you know what? I told you before, no 2 human beings are genetically the same. If not, that is according to Professor Charles Darwin and Lamarck in the theory of evolution. So if 2 human beings are not genetically the same, then they are not likely going to have the same ability. And even if they do the same sport, even if they do the same thing, they are not going to do it the same way. Okay? But you know what? Can we actually have a way to classify individuals, okay, in a particular group, so that we can say, okay, in this group, these guys are really fantastic, and so on like that, okay? And we want to do that by considering 3 variables. If anybody want to assess you, they're actually going to assess you based on certain variables. We actually want to group these 5 players, you know, based on 3 variables. And they are, you know, these guys are basketballers, okay? We're actually going to use rebounds. We're going to use assists, and we're going to use, you know, points. So we're actually measuring 3 variables, and, you know, and these variables are, you know, each is per 36 minutes played. Now, for us to do that right now, we got to calculate the distance between each of the variable, putting into consideration, you know, the players. Now, this is the data set that you're given. Okay, the data set for the 5 players. Can you see the 5 players right now? And of course, this is the rebound, you know, per 36 minutes played, and this is the point. I mean, this is the assist, and this is the point. So you can see the values now. And you know what? The very first thing we're actually going to do is to you know, to set up the distance matrix, okay? And that's exactly what we're trying to do right here. Can you see that now? So to set up this now, you just need to write from the first player to the last one. Look at that, I write it there. Then here, can you see that now? And of course, the distance between the same players is actually going to be 0. Until you know that. You know what? I'm actually going to use the formula right here. If I want to use the formula right here, particularly the one I'm actually showing now is the distance between, you know, the M and X. Okay. If I want to find it out, if I want to find out the distance between the M and S, you know, the 7.2826 that you actually see right here, okay, the 7.2826, you can see in the table, it means I'm looking at the distance between the M and X, okay? Now, if you take a look at the M and X, okay, I'm actually going to be doing this minus that squared, oh no, okay, this minus that squared, and this minus that squared, okay? I'm going to add that, and I'm going to take the square root of that, and this is what I have, and that's how I'm going to do to determine the other one, okay? And you know, when I determine this side, I don't need to determine this side, because the distance between A and C is going to be the distance between the C and A, okay? So now, the very first thing, it means when you are given a data set, okay, you're actually going to set up your matrix table. And let me tell you this, in exam, for you to set up this table for me, you need to first write this formula, okay, because I need to know which method are you using, okay, for you to have an extra credit, okay? So you need to write down this formula for me, okay? Then you can you're gonna show your table, okay? So this is a distance table, okay? It's like a distance matrix table. Okay, this is a distance table we're using. Now we want to do single linkage, okay? And what do we mean by single linkage? In single linkage, we're going to use, you know, if you go back in the single linkage, we're actually going to use the minimal distance to decide on the groups. Complete linkage is maximum. Average linkage is mean distance, okay? So what I want to do right now is actually go to do to do the, you know, the single linkage, which is the minimum, okay? Now, this is and you know what? You actually need to be very careful, because the moment, if your distance matrix, okay, if your distance matrix is wrong, Every other thing you're actually going to be doing is actually going to be wrong. And that's why I need you to be very, very careful, okay? You need to take your time, okay, so that you don't make a mistake, okay? Now, this is the table that we have right now. This is the distance table, okay? Now, if I have a distance table, I need to identify the smallest distance. When I say the smallest distance, I'm not going to be talking about 0. Because when I talk about 0 is just the distance between me and me, okay? So, of course, I shouldn't have, my distance should be 0. I shouldn't have any, I should be the distancing from myself. Okay, you understand what I mean? So you don't count the 0 as a minimum. Okay, so the minimum among the numbers here, I mean the number greater than 0, the minimum among the number greater than 0, okay, the minimum among the number greater than 0 is actually going to be 1.7704. Can you see that now? This is a minimum, okay? And if that is the minimum, and this minimum actually occur between A and C, okay, if the minimum occur between A and C, then it means I'm actually going to match A together with C because they have the minimum distance. And that's why I'm actually going to match them together, okay? So imagine A and C together. If I want to create a new table, okay, before the entries in the table, if I want to create a new table, since I've matched A and C together, it means I'm actually going to have the combination of AC and MST. Look at that, MST. Then I'm also going to have MXT. Can you see that now? Now, so the very first thing I'm going to do before, completing the entries in the table, I'm actually going to put 0, 0, 0, 0 in the diagonal. Then the next thing I want to do now, how do I decide on the first entry in the table? That is deciding between, deciding on the first entry, how do I come about 3.8521? Then it means I'm actually need to be looking at the minimum distance. Now, if you take a look at the step right here, like I said, I'm combining A and C, okay? And in a situation where I'm combining A and C, okay? Now, when I say A and C, okay, the AM that you are seeing here, in order not to create confusion, when I say AM, I mean A, okay? When I say A, I want you to get what I'm trying to say now. If you take a look at what I have right here, A and C is the one that I'm combining. And when I'm combining A and C, okay, so A here, A is the same thing as AM, okay, and C is the same thing as CP. Don't forget that the players have the last name and the first name, okay? It doesn't really matter. So now when you take a look at that, it means if I combine A and C, okay, then it means if you take a look at what I have right here, I'm actually going to be looking at the distance between M and AC, X and AC, and T and AC. Because if you take a look at what happened here, we have combined A and C together. Then it means what I'm actually going to do, I need to look at the distance between M and AC, S and AC, T and AC. Okay, now if you take a look at what I have, what I'm doing right now is the distance between M and AC. Okay, that is the distance between M and AC that I combine. And you know what? If I want to look at the distance between M and AC, of course, if I want to find that, if you take a look at what I have right here, 3.8521, 4.0278, if you come to this side, if you come to this side right here, okay, 3.8521 and 4. If you take a look at this is what I'm talking about. Can you see that now? This is exactly what I'm talking about. Okay, so I'm talking about this right now because I've combined AC. Okay, then right now I'm looking at the distance between AC and M. If I want to look at the distance between AC and M, okay, I need to look at the minimum of these two values. okay? And the minimum of these two values is actually this, okay? Now, if I want to compare, that with the S, if I look at the AC and S, okay, what is the minimum here? What is the minimum between 3.7019 and 5.2001? Okay, the minimum is going to be this guy. And look at this guy here. And the last thing here, what is the minimum here? Okay, if I were you, what you're just going to do is just that, okay, from here, if I want to get to this place, what is the minimum here? What is the minimum here? And what is the minimum here? And the minimum is what I actually write here. Can you see that now? And that is 3.8521, 3.7019, 3.9708. So the minimum of that is what I actually write here. Okay? So is there anyone who doesn't understand how I figure out this minimum? Is there anyone who doesn't understand?
Professor?
Okay.
So what if instead of A and C we combine, in another problem we should combine A and say S, and then how would we do the rest of the column then?
Actually, I think you know the reason why we. Do you know the reason why we combine A and C? You know the reason? Yeah, the
Because
reason.
the first column A and C, that cell is the smallest.
Okay, you can see. You can confirm the 1.7704 is the smallest?
Yeah.
Okay, thank you for that. Now, if I match A and C together, then it means, my table. What will happen to the table? The table will shrink. So, which means cluster analysis is another dimensionality reduction technique. Now, if I combine, it means in the new table, I'm actually going to have AC combined. Then I'm still going to have MST. Look at that, MST. But how do I decide on this particular value here? If I want to know how to decide on this, then I'm actually going to come right here. Since I've used this to match, then I'm just going to come down. Then I'm going to choose what is the minimum here. The minimum here is 3.5821, and that was why I wrote this. Then if I want to know the next one, I'm actually going to come down here. What is the minimum here? The minimum is 3.7019. I'm talking about the minimum between this and this, okay? And that is what I wrote here. Now I'm going to come down now. What is the minimum here? I'm talking about, I'm still using AC on T now. That does not include all this. Just this guy here, these two. What is the minimum? The minimum is 3.9708. Look at that. Okay? Now, which means I've done entering this. The next thing that I'm actually going to do is to move now, to decide. If you now take a look at this one here, if you take a look at the remaining 3 entries, okay, the remaining 3 entries, if you want to get the remaining 3 entries, you're actually going to go back to the table right here. Now, do you understand how I figured this out now?
Yes, I understand about this table. What I was asking was like, what if in another problem, instead of we merge A and C, we should merge another 2 cells, and then what would that be in the case of like filling the merged table?
Yeah, based on what we have right now, you cannot merge anything other than A and C as the first one.
Yeah. I'm just wondering, like, what if in a new problem, like we should merge 2 different cells? And
Can you say that again? I want to get you clearly.
yeah, I was wondering, like, what if in another problem, like not this problem, but like a similar one, but in that situation, we should merge 2 different cells. Say
Oh,
first row and the 4th row, maybe. And then if that's the case, how would we do the merge table?
oh, I get your question now. Now, if I get you clearly, what you're trying to say is that, okay, when you are given any question, okay, we actually go, let me just tell you, if you're given any question, you're actually going to match, the cell that you are going to match will be the one that have the smallest. It doesn't really matter, you know, right now, if you look at this is coming as a first and the second. There's possibility that the smallest may even be here. The smallest can be in any, you know, any of the cell can be smallest. But the strategy remains. If, for instance, if the smallest is this, okay, let's say I'm just assuming right now, if this is the smallest, then what I'm actually going to do, it means I'm actually going to match M and S. I'm actually going to match M and S. And if I match M and S, it means in my new table, I'm actually going to have MS, then A, C, T. Does that make sense to you now?
Yes, that makes sense.
Okay, so it doesn't matter whether, you know, it is only here that you have A and C, that are side by side. It doesn't really matter. You know, the law says that anywhere I identify the minimum, therefore, the players or the item that will be matched will be the item that correspond to that particular cell of minimum. And you know what? You're actually going to see by the time we get to maximum, which I call the complete linkage, and by the time we get to average, you're going to see that, they are not likely to be, side by side. Okay, so you have asked a very good question. Thanks for asking that question. Okay, now, like I said, we have been able to decide on that. Okay, so we got 3.85, 3.709, 3.90. So this is what we have. But if you take a look at this, okay, M and X, the M and X will remain M and S. You're going to pick that from this table right here. Can you see that now? And M and T will remain M and T. You're going to pick that from that. And you're going to pick that one. You can see that now. So it means the only one, the new member, the only thing that will determine are just this guy here. And how do I determine this guy here? You know, I just look at that. Can you see that? The minimum. Okay. Now, this is where we are now. This is a new table. You can see in the new table, the dimension has actually been what? Reduced. But you know what? We still want to reduce this dimension. The next thing we're going to do now, where is the smallest? Here. Okay? We're going to look at the smallest. And you know what? 3.8521 is the smallest. Then you do the same. Okay? When you do the same, you actually go to, is there anyone among you who doesn't understand how I got to the final table? Is there anyone who doesn't understand? Because you're still going to do the same thing all the way. Is there anyone? This is my final table right now. Is there anyone who doesn't understand how I got this? Is there anyone? And you know what? How do I know that this is my final table? Because I only have one number aside 0. This is one number. Okay? And let me tell you something. What implication? What do you have right here? It's more or less, it look as if you have categorized the 5 players into 2 groups. ACMS in one group and T automatically in a different group. Can you see that now? It means out of 5 players, 4 A, C, M, and S have similarity, have have something in common, okay? And that is the reason why they're actually going to be grouped together. Can you see that now? It is only this player, T, that is actually different from them. Okay? So we got 2 groups right here. And let me tell you something, we did not know these 2 groups ahead. And that is the difference between this and the classification, discriminant and classification analysis. Okay, so when you now take a look at that now, we're actually going to call that ACMST. If you look at the combination, okay? Now, I talk about dendrogram. I want to confirm to you, the dendrogram will be part of the exam. Now take a look at what I have right now. What was the first thing we merged? AC, right? And AC was merged. What was the element? What was the minimal element for the margin? Reason for the margin 1.7704, right? In my dendrogram, take a look at that. AC and DC, this actually corresponds to 1.77, which is the minimum. Okay, I'm going to take you back now. We are able to match A and C because of this, right? 1.7704. You're actually going to show that look at that. This is the distance against the players. So it means initially, when I started, we matched A and C. And what was the minimum distance between A and C? It was 1.7 something. And after merging A and C, what was the next thing that we merged? It was AC and S. Okay, it was AC and S. And when we merge AC and S, what was the distance? What was the minimal distance to be able to merge AG and S? The minimal distance was 3.8521. Okay, let's go. Let's go. Oh my God, look at that. ACS. You're actually going to start from here. Look at that. This corresponds to that 3 point something that I talked about. Okay, what is the next in my margin? My next in my margin, if after the ACS, then we move to ACMS. Okay, and you know what? You saw that thing for that. It's still 3 point. Take a look at that. Can you see that now? And the last one that we match, okay, the last one that we match, if you take a look at the last one that we match, ACS, ACSM. Okay, I mean ACMS. Okay, the ACMS, of course, it was 3.5821. Now this is the dendrogram. Look at that. We can start from AC. After the AC, we go to ACS, and after the ACS, you continue to move to ACSM, and from there, lastly, then ACSMT. Is there anyone who doesn't know how to sketch this particular dendrogram? Is there anyone who doesn't know how to sketch that? And what are we using to sketch the dendrogram? We are actually using, the margin, the minimum. If for dendrogram, for AC, this is the minimum. For ACM, okay, for ACS, this was the minimum. Okay, for this ACS, this was the minimum. Now, and for ACS, for ACMS, this was the minimum. I think you see that now. So that was what we sketched right here. Okay, the next thing that I want to talk about, if you understand the minimum, you're going to understand the maximum. Oh, how does the maximum, how does it differ from the minimum? You're going to see right now. I'm going to start from the distance table again, but this time around, I'm actually going to start from the maximum. Okay, and what is the maximum? Okay, if you look at the table right now, what is the maximum? Okay, so you have 5.25, 3.907, the 8 point, and so on like that. Okay, so if you take a look at, said the closest when we first started, let me tell you this. We are still going to focus on the minimum, but only that when we want to decide, the other time when we were deciding, we were trying to choose the minimum. Okay, now let me tell you this: whether you are working with the minimum, whether you are working with a single linkage or complete linkage, okay, single linkage is we're using minimum or true, right? But in the complete linkage, your step one, you still need to start from the minimum of the cell. Okay, you still need to start. I'm still going to start from the, if you take a look at this now, it's still what the minimum is 1.7704. Okay, now if the minimum is that, so which means I'm actually combining A and C, but you know what? The element here, if I now want to consider, here, I'm not going to consider the minimum here. I'm actually going to be considering the maximum. Okay, what is the maximum of 4.0287 and this is 4.0? Look at that. What is the maximum here is that. What is the maximum here is that. I'm going to state that again. We're still going to use the idea of the minimum on what to match. Whether you are dealing with a single linkage or complete linkage, you're still going to use the idea of minimum cell to determine which one to match. But you know what? By the time you are now deciding on the elements, on the entries, you have to use the maximum. Okay, so that was how I got all this. Okay, the maximum of that. Okay, so, and from here to, you're still going to use the minimum again. Okay, when you get here right now, the minimum is this. Okay, and if the minimum is this, then the next thing you can do now, if you want to decide on every other one, you're going to decide on the maximum between this, maximum between this, the maximum between this and this is this maximum. So you have that. Now you're still going to use the same thing, up here. Take a look at this. What is the minimum here? The minimum is this guy here. Okay, and if this guy is a minimum, then the next thing now, what is the maximum between this and this? Is 8.39. That was why I got this. Is there anyone who doesn't understand how I arrive at this table? Is there anyone? Okay, then you can draw your dendrogram on that too. Can you see that now? Now, the next thing now is we want to talk about average linkage. How do we do average linkage? Oh, it's not special. You know what you're going to do? What you're going to do, you're still going to start with the minimum. Oh, because I told you whether you are dealing with a single linkage or you are dealing with a complete linkage or you are dealing with average linkage, to decide on which of the item to match, you're still going to use minimum. But when you use minimum, like in the case of a complete, in the case of average linkage, I know I'm actually going to match A and C. Okay, if I want to match A and C, how do I decide on the elements here? If I want to decide on this one, I'm not going to use the minimum, I'm not going to use the maximum, but I'm actually going to use the average. What is the average? Oh, this guy plus this guy divided by 2, and that is actually going to give me this. Oh, this plus this divided by 2, I'm actually going to have this. Oh, this plus this divided by 2, I'm actually going to have this, and that is what I'm actually going to write. Oh, this is so easy. Is it not easy? Are you guys finding it easy to do? I need you to okay, thank you for that. So easy. So when I decide on this one, then of course I can write the other one. Look at that. That is what I'm also going to do again. Okay, and this is what I got. Okay, can you see that now? Is there anyone who doesn't understand? Who doesn't understand? Is there anyone who doesn't understand what I just did? Who does it? Now I'm confirming to you in the exam, you're actually going to have a question where you need to find the single linkage, you need to find the complete linkage, and you need to find the average linkage, and they're actually going to ask you to draw the dendrogram. Is there anyone who have a trouble time understanding what I'm explaining right now? Is there anyone? Okay, so this is the dendrogram for that. Can you see that now? And that is going to be the end of the lecture. Is there anyone who doesn't understand? Is there anyone who want to ask question? In the exam, you're actually going to see a question from cluster analysis that would look like this. The probability is 1 that you're actually going to see that. Is there anyone who want to ask question? Is there anyone? Okay, silence implies that you guys are good. Now, I'm actually going to have a new share right now. I'm going to use the next 10 minutes to actually talk about a particular material, our material that I share with you, you know, in case you guys actually want to do something in R, cluster analysis in R, okay? I need you guys to confirm if you're seeing what I'm actually projected right now. Can you see that?
Yes.
Thank you so much for confirming that. This is a material. This material was not written by me. That is the name of the person that wrote the material. But I actually find it very useful, okay? I find it very useful. And that was why I'm trying to share this material with you, okay? It's a practical guide to cluster analysis in R. And let me tell you this. This is basically for cluster analysis. But I'm gonna walk you through the area that is very, very interesting. Okay, very, very interesting. Now, take a look at, if you look at the content, if you look at this area, method of measuring distance, how do you do that in R? What type of distance measure should we choose? I showed you the other time we have different kind of distance measure, okay? Data standardization, distance matrix computation. You know, I showed you how to do that manually the other time. You can do that in R, okay? Visualizing distance matrices and so on like that, okay? If you exploit this book, it has a lot, okay? This book actually has a lot, okay? So I attached the material just for you to be able to, but there's something, okay, look at that. Look at the dendrogram that I just talked about the other time. Can you see the dendrogram? Okay, there's something that interests me that I'm actually, take a look at this. Here you are trying to look at the dendrogram, you know, comparing to dendrogram. Okay, how can we compare to dendrogram? Look at the dendrogram, I showed you how we constructed 3 dendrogram the other time, one based on single linkage, another one based on the complete linkage, and the last one was based on the average linkage, okay? So what is the connection between them, okay? So take a look at that, okay? So you can exploit, if you exploit the book, you know, you're actually going to enjoy that a lot, okay? It contains a lot of essentials. But I'm actually going to, but you know what you need to load? You need to have a package loaded. You need to load some packages like cluster. You need to, install all those ones, packages, before you can actually run what I'm talking about, okay? But there's something I'm actually going to show you. Give me 1 second. I'm actually going to show you something now. Okay. Take a look at the data set right here, okay? If you copy that data set into R, okay, you can work on it, okay? And take a look at this. In fact, let me do this right now. I'm going to copy this right now. I'm going to copy that right now. US arrest. I'm interested in that data set, okay? US arrest. Let me go to my R right now. There's something I'm actually going to show you. I'm going to stop my share, and I'm actually going to go to R right now. I want us to use the data set US arrest, okay? But let's see what is in the data set, okay? We actually want to see what is in the data set, okay? Now, I need you guys to confirm if you are actually seeing my, if you see my arrow interface right now. Can you guys see my arrow interface right now?
Yes.
Okay. Give me 1 second. Okay, so well, let me copy that. Now, this is US arrest. Okay. Now, I'm going to copy, it's going to load the data for me right now. And if I copy, the data now, let's see what's going to happen. Okay, so give me 1 second. Okay, can you guys confirm? Can you guys confirm this right now?
Yes.
This is arrest made by, you know, law enforcement agency in the United States of America across state from Alabama to Wyoming. Okay, and you know what? For murder, for assault, for urban, and for rape. Okay, so you have 4 variables right here. Okay, now I'm going to write something right now. I'm going to copy, like if I'm interested, at times you may not be interested in all of them. You may not be interested in all of that. If I'm only interested in Alabama, Alaska, and Arizona, okay, I may not be interested in all of the states in the United States, okay. I may be interested in Alabama, Alaska, Arizona. You're going to see that I put 3. Why do I put 3? Because Alabama, Alaska, Arizona, that is the first 3, okay. You can extend that, okay. It depends on the question that they actually ask you, okay. So that depends on the question they ask you, okay. Now you can do whatever you want to do with that data set. Now let me just assume that with the data set right now, okay, maybe I actually want to scale it. Give me 1 second. If I use df to name the data set right now, if I use the df to name the data set, okay, and I click on that, my data set is now df, the USRS. I named that as df, okay. And you know what? And what I actually want to do is I actually want to scale it. Okay, how do I scale it? Okay, I actually want to scale it. Okay, why am I scaling it? Okay, so if I want to scale it, if I want to know what is there, you know, I scale it because of the, you know, remember the other time we need to standardize. Okay, now what I have right here now, it has been standardized. It's different from what I have. What if in a situation where examiner give you a question like this? Examiner can ask you to perform anything. Examiner can ask, you know, in a situation where your variables is more than 1, examiner can ask you principal component, examiner can ask you factor analysis, examiner can ask you to do anything. Examiner can ask you to do cluster analysis. You can do anything on your data set. Okay, so now take a look at what I have right here. This has actually been, you know, these are standardized. Okay, now the next thing I actually want to do right now, if I want to only extract for the first 3, if I want to extract for the first 3, I'm actually going to, so these are the standardized, you know, variables, you know, for the Alabama, Alaska, and Arizona. Okay, I can do a lot. I can do whatever I like. Okay, now another thing that I want us to do now, how do we do clustering distance measure? Okay, I showed you the other time we have Euclidean distance. You know, when you were setting up your distance matrix, okay, you know, if you want to do either if you want to do single linkage, or you want to do a complete linkage, or you actually want to do average linkage, you need to first set up your distance matrix. Now, how do we compute distance matrix in R? particularly if you have a lot of data set that you may not be able to do manually. Okay, how do we do a distance matrix in R? I'm going to show you right now. The one that I call Euclidean distance, okay? The one that I call Euclidean distance, I'm actually going to show you right now how you can actually do that. So give me 1 second. I'm going to copy that right now. Okay, so I'm actually going to write, but you know what? If I want to do the Euclidean distance, I'm actually going to use the standardized. You can see the way I started. I first standardized. Now I'm going to copy that into R right now. You're going to see right now. Can you guys confirm if you are seeing this right now? Can you see that?
Yes.
Okay, so the distance here, Euclidean, you're going to write dist in R, Euclidean, okay, Euclidean distance. Actually, want to set up a distance matrix, okay? So click on that, okay? When I click on that, I'm actually going to copy this guy now. Okay, give me 1 second. I'm going to do this. Okay, try to delete that one. Oh my God. Take a look at what I have right now. This is the distance matrix. But you know what? In R, R will not compute the distance matrix you are going to have will not include 0, 0, 0, 0. Because R will not compute the distance between New Jersey and New Jersey. It will not compute it because I will actually know that's going to be 0. So you are not going to have it in your, look at that. This is a matrix. It's going to be triangular. So this is a distance now between, you know, the Washington and New Jersey. The distance, Euclidean distance between Maine and New Jersey. So what I have right here is the, you know, how you can do the Euclidean distance in R. Is there anyone who doesn't understand how to go about this one? Is there anyone? Okay, so this is how to do that now. So easy, right? If you are working with, you know, any kind of data set, you know, if you have a lot of data set, of course, if you want to do the Euclidean distance, okay, if you want to find the Euclidean distance, that's actually what you are actually going to get. Can you see that now? Okay. The next thing I'm going to show you before I go, do you know that you can actually extract out of the matrix that we have, we can actually extract for 3 particular states. Okay? Now, take a look at what I have right here now. Now, if you take a look at what I have here, this one will look like the one we have been doing. How does it look like the one we've been doing? Because it has 0 in it. Can you see that now? So if a situation where, look at that, New Jersey, that would be 0. Washington, that would be 0. Utah, that would be 0. Now right here, if you take a look at what I have right here, I'm only having, you know, 3 states: New Jersey, Washington, and Utah. Can you see that now? So the moment you exploit that book, of course, is actually going to give you a clue. You know, I believe you're actually going to gain a lot from that. Okay, another thing that I also want to talk about is let me see. Give me 1 second. Okay. If you look at the stage that we have considered in the United States, okay, the one I call the USRS, if we want to group this state to similarities or dissimilarities in terms of, you know, murder, though I actually need to install a package. I told you you're actually going to install a package called cluster, and not only cluster, you're also going to install factor extra. okay, you're going to install factor extra. I'm going to load that right now, and you're actually going to see what I'm talking about, okay? I'm going to load that right now. You're going to see what I'm talking about, okay? Now, can you guys see factor extra? I need to load factor extra, okay? And if I load factor extra, now the next thing that I'm actually, that I actually want to do right now, I actually want to do the grouping. So I'm going to write the code, and you're going to see what is actually going to come out of the code. So I'm going to write, give me 1 second. Yeah, I'm going to write that. And I'm actually going to copy that now. Can you guys see what I just copied right now? You know, FVIS underscore DIST, then this, you know, this is the equally, you know, this guy here is just talking about this, okay? He's talking about the distance matrix, okay? Now, if I click on enter, oh my God. Can you guys see what I'm seeing right now? Can you see this right now? Okay, can you see this right now? So we got the blue one, we got the red one. Can you see that now? Okay, so if you take a look at what I have right here, we actually have a key. Okay, we actually have a key, and I'm going to show you. I'm going to have a new share where I'm actually going to explain that to you right now. You're going to see what I'm talking about. Okay, can you guys see my screen right now? Can you see my screen right now?
Yes.
Okay, thank you. Now take a look at that. Like I said, we're actually gonna have a queue. You know, now the ice red is the ice similarity. Okay, you know, when you are looking at the similarity between states in the United States in terms of, you know, the arrest, you know, and don't forget the arrest. People are arrested on the fact that they are alleged of probably being maybe alleged of rape, alleged of murder, and so on like that. Okay, we now want to look at the similarity, okay, among states. Okay, so I similarity, of course, I similarity means low dissimilarity. Okay, so I similarity, the one in red. Can you see the one in red right now? The one in red, okay? The one in red is I similarity, okay? And the one in blue, when you see the blue right now, the one in blue means low similarity, okay? So this particular picture here look like something like an, you know, image, or this look like an image separation, okay? We're using like image processing right here, okay? We are actually using that to explain similarity among states in the United States, okay? Among states in the United States in terms of the characteristics, you know, the data set we're using right here is talking about the arrest made by the law enforcement agency, you know, the arrest made by the police, okay? You know, people were arrested on the allegation, on different kind of allegation, okay? But here, this will enable you to compare whether there's a similarity, okay, in, you know, among some states. So I want to tell you some states, we have the high similarity, and some states we have the low similarity. And if you take a look at that, I say the color level is proportional to the value of the similarity between observation. Okay, pure red. When you say pure red, you know, pure red, we actually tell you pure red, the distance, you know, pure red is a perfect one. It's more or less talking about exactly the same state. And you know, no two states will be exactly the same in terms of arrest, in terms of, you know, allegation of maybe rape, murder, and so on like that. And that is the reason why, you know, when distance equal to 0, you know, that is a pure red, okay? But you know what? We don't expect to have a pure red, you know, before we can actually, you know, put some a particular state in a group. Okay, it doesn't need to be pure red. Okay, because the pure red means I'm still talking about the same state. Okay, and for pure red, the distance is actually going to be 0. And for pure blue means that, the distance is actually going to be 1. Okay, the distance is actually going to be 1. For your information here, we are actually talking about the distance of a standardized. We're talking about the standardized variable. Okay, now take a look at that. And that was why the object belonging to the same cluster are displayed in consecutive order. Okay, so make use of the legend right here. This is going to be the end of my lecture today. Is there anyone among you who need clarification before I end my lecture today?
Professor?
Yep.
I'm sorry, but could you probably like illustrate a little bit more about how do you go about step 2 and 3 in the previous slide when we're getting the distance, what's that called?
Okay.
The linkage?
Thank you so much. I'm so excited. I'm going to do that. I'm going to show you. I like that question, okay? I'm going to show you right now. I need you to confirm if you guys are seeing the lecture material right now. Can you guys see the lecture material right now?
I can see it.
Okay, thank you for confirming that. Okay, so you actually want me to to explain the step 2, okay, and the step 3.
Or actually step 3 and 4.
Oh, you mean step 3? Is it step 3 and 4?
Yes.
Okay, now this is a situation, they are linked together. But you know what? I will not only explain step 3 and 4. I'm actually going to start from step 1 so that you will really understand. Now, this is my data set. Okay, and what I have right here is the distance. But you know what? The distance metric that I have here, these values have not been standardized. This is getting a direct distance, okay? I did not scale it, okay? Examiner is actually going to tell you whether you're going to scale it or not. But right now, I'm not scaling that. Okay, now, of course, you know how to get this. Now, how do I move from here to here? If I want to move from here to here, I'm actually going to start step 1. I need to look at the smallest. And the smallest here is 1.7704. And that falls in the intersection between A and C. Then it means I'm actually going to merge A and C together. If I merge A and C together, so I'm actually going to have AC, then MSC. So that will be my table. And in my table, I will, for of us, write the diagonal is actually going to be 0, 0, or true. Now, the next thing, how do I get this column? How do I get this column here? To get this column here, I'm talking about this column here, I'm actually going to come here. What is the smaller? What is the smaller? Which one is smaller between this and this? Oh, it's 3.8521. That is a smaller number between these two. And that's what I write here. What is the smaller number between this and this? That is 3.7019. That's what I write here. What is the smaller number between this and this? And that is 3.9708. That's what I write here. The moment I decide on this smaller one, I'm actually going to come back here and write every other one. Take a look. I'm going to write 7, MS. The next thing I have to do is MS. What is the entry? I'm going to write this guy here. Okay. And I'm actually going to put this guy here. I need to put this guy here. I'm done with the first one. Do you understand how I did the first one now?
Mm-hmm.
Now, now to go to the next one, I'm actually going to make use of this guy here. Oh, what is the smallest? Like I said, I'm going to ignore 0. Okay, I'm going to ignore 0. So the smallest is this guy here. Oh, 3.8521 is this smallest. So if this guy is the smallest right here, then it means I'm actually going to match ACM.
I think the smallest will be the 3.7019.
I'm sorry. I'm sorry. You know, I mentioned ACS. So the smallest is 3.7019. So I'm actually going to match ACS. Okay. So I'm going to match ACS because the 3.7019 is the smallest or true. Okay. Now, when I match ACS, it means in my new table, I'm actually going to put ACS. And when I put ACS, I'm going to write M and T. I'm not going to write S again. So that's why you see M and T. And you know what? In my new table, I'm actually going to write the diagonal 0, 0, 0. And when I write the diagonal, I need to decide on the element here. So I'm actually, if I want to decide on this one here, then I'm actually going to, I'm actually going to come here again. Okay. Now, if you take a look at what I'm trying to talk about right now, so from there, you're actually going to decide on what I have right here. Okay. So, and when you decide on what you have right here, you're actually going to see that, the value right here is just coming from here. Can you see that now? So 6.0415 is just coming from here. Of course, you decided on this value right here. Of course, automatically becomes that one. And you decide on this one right here. Of course, you choose that one. Okay. And some of you will say, why do I have to choose? Why do I have to choose 3.8521 again? Because here, of course, it is the smallest. Okay. I'm not going to consider 0. Don't forget that. I'm not going to consider 0. I'm going to ignore 0. So because I only have this guy, is still what I'm going to take. That's why you have it. And the moment you have this one now, what is the smallest here? 3.85, 3.97. Of course, it's this guy. It means I'm actually going to match ACSM. ACSM. So if I do ACSM, then in my new table, I'm actually going to have ACMS, then I'm and T. Look at that. I'm just going to put T. Okay. And automatically, it's going to be this guy here. And this is a final table. Do you understand that one now?
I guess I understand the part when we're like deciding which part we should merge, but in terms of how do we manipulate the rest of the numbers, I'm still a little bit confused.
How do you, you mean manipulating the rest of the number? Okay, which means you know how to match right now.
Yeah,
But
I know
the
how
issue
to merge.
is, okay, I'm gonna repeat that again. Okay, I'm gonna start from here again. Take a look at this. This is the data set you're given. Okay, you get this matrix in place, the distance matrix, and when you get the distance matrix right here, the next thing that you're actually going to, in fact, you can look at the step right here. But the next thing you're going to do is, okay, the smallest cell will give me the idea of what I want to match. Oh, I'm matching A to C. And if I'm matching A to C, it means I'm collapsing. I'm collapsing this, okay? So it means in my new table, I'm actually going to have AC that I've combined, then MXT. Now, I need you to first set up the table, okay? You can see right here, you have a 1, 2, 3, 4, 5, 6. The dimension has reduced. So when you set up this table, I need you to first write in the diagonal, you need to first write 0, 0, 0, 0, okay? Now, after writing 0, 0, 0, 0, what is the next thing? The next thing is you need to determine the rest of the elements in this column, in the AC column. And how do I decide on this? Then I will come back here. What did I match? I actually match A and C. Okay? If I match A and C, then you know what you need to do? If you match A and C, the next thing that you're actually going to do is to look at this. This is row 2, right? This is row 2. My focus is going to be on row 3, row 4, row 5. Take a look at that. Row 3, since this is the smallest is in row 2. Okay? Then my focus is going to be row 3, row 4, row 5. Okay? And in row 3, in this row here, I'm actually going to be comparing this guy and this guy. The one that corresponds to the AC. Okay? the one that corresponds to the AC, look at that. I'm not going to extend to this side. Because when I extend to, even if, because there's possibility that maybe you have something here that is not zero. Maybe that is something else. That's what I mean. But let me tell you something. The moment you have 0, 0 right here, you are not going to have anything here. Because what you're going to have here is going to be something that you have already had here. So now, how do I compare? You now compare this. What is the minimum between 4.0287 and 3.8521? What is the minimum? The minimum is this. That is why I wrote it here. What is the minimum here? Okay, the minimum is 3.7. That's why I wrote here. What is the minimum here? If you look at me, I'm still talking about AC. Look at the row, AC row. Then I got this. The moment you got this one, okay, you don't need to do AC row again to be able to get the other one. Automatically, if you want to get this guy here, you come and pick it and look at M and S. Is that guy? Because this is TM and S. This guy here, M and T. This is TM and T. Look at that. This guy here, S and T. This is T. You know, can you see that now? So which means I'm still bringing some values, okay, from here to here. So which means the new thing that I just discovered right now is just the one that corresponds to the AC, row here, the first two. Can you see that now? And the same thing that I do here. How do I know which one to match? Right here, I look at the smallest. This is 3.85. This is 3.70. Let's see. Okay, this guy here is the smallest. If this guy is the smallest, then it means I'm actually going to match ACS. Look at that. If I match AC and S, then I'm going to be left with M and T. Look at that. That was why I write ACS, then M and T. What I wrote here is what I wrote here. Okay, the very first thing I'm going to write is 0, 0 in the diagonal. And when I write the 0, 0 in the diagonal, the next thing I'm actually going to do is to decide on the element in the first column. Which column am I talking about? Is this ACS? Okay, and if I want to talk about ACS, okay, it has to be, I'm talking about this all the way. Look at that. This is AC, this is S, all the way, all the way. What is the minimum? But don't consider 0. I told you ignore 0. Okay, so I think you can see that now. So look at that. You look at this one all the way. You look at that one look at that. That was why we have this. If you take a look at this one now, what is the minimum? It's 3 point that. Can you see that now? When you look at that, what is the minimum? Can you see that now? Okay, you have this one now, 3.8521, 3.9708. Can you see that now? And what is the last one? I need to decide on the MT. MT is going to be this guy here, and that was why you have it here. Now, this is the last table. This is the second to the last table. What is the smallest? Oh, okay, if I have 3.8521, if I have a 3.9708, if I have this one, this is going to be smallest. It means I'm actually going to match ACSM. If I match ACMS, this is going to go away. I'm only going to have ACMS and T. Look at that, ACMS and T. Then I need to first write 0, 0. It means there is only one value that I need to decide on. And how do I get the value to decide on? Then I'm actually going to come here. Look at that. What is the minimum here? I say you have to ignore 0. The minimum is that. Then I'm done. Do you understand now?
Yes, I guess I understand it.
And you're going to do the same thing for the complete. The only thing is that for complete, you're still going to use the minimum to match. But by the time you want to get elements in the new cell, you have to use the maximum. And for the average, you're going to find the mean. You're still going to use the minimum to determine this what to match. I want to appreciate everyone for attending my lecture today. I hope you guys enjoying it. Until tomorrow again, and I'm actually going to come your way with, we're not going to, not with another topic, But this time around, we're going to have a final review. The final review actually starts tomorrow. I want to appreciate every one of the students who have been, attending my lecture since the beginning of this semester. I want to say you guys are the best. You guys are, you are very, very nice because you normally listen to my lecture, you cooperate with me, and I have the feelings that you guys are actually going to pass this exam excellently. And at the end of the day, your dream in life, your goal in life will be fully achieved. You're gonna rise and rise and rise. There's no limit to how you're gonna rise in life. Okay, you're gonna continue to rise and rise and rise. You're gonna fulfill all your expectation in life. So make sure you stay safe and have a good day.
Thank you.
You're
Thank
welcome.
you.
You're welcome.